For this video, I want to go over some examples of what we need to do for the 13.3 skills practice, which is titled Trig Functions of General Angles. So let's look at number 2 first. Sort of as an example, we'll do a couple of these. It says find the exact values of the 6 functions of theta if the terminal side of the angle in standard position includes the given point. So what we need to do is, before we do anything else, we need to plot the point 3, 4 that they give us. We're over 3 and up 4. So now at that point there, this is point 3, 4. We want to draw the right triangle that goes with 3, 4. Now if the x-coordinate is 3, that means this side is a 3, and this is a 4. We need to find the hypotenuse. This is a 3, 4, 5 Pythagorean triple, or 3 squared plus 4 squared is 25. Square root of 25 is 5. So the hypotenuse is 5, and we have the angle located in standard position. So they want us to do the 6 trig functions, so I like to just write all the functions down. So I have cosine theta, sine theta, tangent theta with equals, and then the cofunctions. Sine goes with secant, cosine goes with secant, sine goes with cosecant, and tangent goes with cotangent. Sine is adjacent over hypotenuse. 5 is the hypotenuse, 3 is the adjacent, so we get 3 over 5. Sine, opposite over hypotenuse, 4 over 5. Tangent, opposite over adjacent, 4 over 3. We want to do secant, cosecant, and cotangent, which are the inverses. So secant is cosine flipped upside down, 5 over 3. Cosecant is sine flipped over, which is 5 over 4. And cotangent is tangent flipped over, which is 3 over 4. So here we have the exact values of the functions and cofunctions that go with an endpoint of 3, 4. Let's look at number 4. So number 4, we want to again plot the point. So we're at negative 4, 3, negative 4 in the x. This doesn't have to be to scale. You just kind of want the relative position, which is there. And we want to draw the triangle. Now we need to think that this, since this triangle is actually in the second quadrant, sine is positive, but cosine is negative. So if we bring ASTC into this, we see that the sine ratio is going to be positive, but cosine and tangent are going to be negative. So that's something to keep track of at the end. If this is 4, distance of 4, the x-coordinate is 4, and the y-coordinate is 3. So we want to do the same thing. Cosine, sine, tangent of theta, secant, cosecant, and cotangent of theta. And we want to write those ratios. We need to find out what the hypotenuse is. This is another 3, 4, 5 triangle, so the hypotenuse is a 5. Otherwise I would have to do Pythagorean theorem. 3 squared plus 4 squared, take the square root and get the 5 that way. Most of these you're going to see end up being some sort of Pythagorean triple, just to make the numbers easier. Cosine is adjacent over hypotenuse, which is 4 over 5. I'll worry about the positives and negatives after we get done. Sine is opposite over hypotenuse, that's 3 over 5. Tangent is opposite over adjacent, that's 3 over 4. Secant is cosine inverted, which is 5 over 4. Cosecant is sine inverted, which is 5 over 3. And cotangent is going to be 4 over 3. Now in the second quadrant, which is where this angle is located, we have that sine is positive because it's positive y over the positive hypotenuse length, but cosine and tangent are negative because they both involve a negative x. So we need to stick a negative sign in front of cosine and secant, and stick a negative sign in front of tangent and cotangent. And we've got those. The next section wants us to find a reference angle. It says sketch each angle, then find its reference angle. So let's look at number 8. This is a positive angle, so we're going around in a counterclockwise direction. And I like to count by 90s. So I've got 90, 180, and 200 is 20 more degrees. So I've got approximately 20 degrees past the 180 down into the third quadrant for the terminal side of that angle. The reference angle is the angle that it takes to get back to the x-axis. This is 20 degrees past the x-axis, so my reference angle is 20 degrees. So that's all we have to do for that one. If we were going to go on with this, again, ASTC comes into play in the third quadrant. Tangent is positive because you've got a negative x over a negative y, so the two negatives cancel out. But sine and cosine are going to be negative. Sine is going to be negative because it involves the negative y. Cosine is going to be negative because it involves the negative x. But that's all we have to do for those is find the reference angle. And again, the reference angle is whatever it takes to get back to or up to the x-axis. And then the quadrant is going to be involved when we actually do the angles. Let's look at, say, number 11 down here in this section. We want to find the exact value, which means ratio, of cosine of 270. So we have to think about where a 270 degree angle is. It's positive, so we're counting by 90s. 90, 180, 270 is actually straight up and down along the negative x-axis. So in a past video we talked about how the x-coordinate and the y-coordinate give me the cosine and the sine of the angle, of the quadrantal angle. So the coordinate of this endpoint is actually over 0, down 1. We're going to use a 1 as a length. So we've got 0, 1, 0, negative 1 rather, for the xy coordinate that goes with that point. Cosine goes with the x value, so cosine of 270 is 0. Because 0 is the x-coordinate that goes with that. Let's do number 14. Number 14, they give us pi over 4. Now pi over 4 is the same thing as 180 divided by 4, which is a 45 degree angle. But in terms of radians, this would be pi over 2. Pi over 4 is halfway in between there. This reference angle is going to be whatever it takes to get back to the x-axis. We're actually pi over 4 up from the x-axis. So pi over 4 is our reference angle. And since this is a 45 degree angle, we have to think about a 45, 45, 90 triangle. We've got a 1, 1, radical 2 set of side lengths. They want us to find the tangent. Tangent is opposite over hypotenuse, which is 1 over 1. So the tangent is going to be 1 of pi over 4. It's in the first quadrant, where everything is positive, so we leave it. Now if that had been a 45-degree angle in this quadrant, then sine would be positive and cosine and tangent would be negative. And that would be 3 pi over 4. That would be like pi take away pi over 4 if you had a pi over 4 angle as a reference angle over in this quadrant. Let's look at 19. That's all we have time for then. It tells us that the tangent of an angle is negative 12 over 5, and that angle is in the fourth quadrant. So we actually, okay, we want to sketch that into the fourth quadrant. It says that tangent is negative 12 over 5. Tangent goes with opposite over adjacent. The opposite side is 12. And the adjacent side is a 5. So we actually have this triangle that looks like this. Here's my angle. And you can see that this is actually like negative 12 over the 5. And let's see, what do they want us to do here? Find the exact values of the remaining 5 functions. So we need to find, might as well do all of these. Sine, let me move this over. We need to find sine, cosine, and tangent. We already have tangent. And cosecant, secant, and cotangent of the angle. Try to stay in the window here. Have to find out what the hypotenuse is. We've got another Pythagorean triple. This is a 12 with a 5, and 12 squared and 5 squared adds up to 169. The square root of 169 is a 13, so this hypotenuse is actually a 13. So sine is going to be opposite over hypotenuse. It's going to be 12 over 13. Cosine is going to be adjacent over hypotenuse, 5 over 13. I'm going to attach the signs later based on the quadrant using ASTC. Tangent is opposite over adjacent. They told us that's the negative 12 over 5. Cotangent then is going to be negative 5 over 12. Secant is going to be 13 over 5. And we want to leave these as fractions. And cosecant is going to be 13 over 12. Now in the fourth quadrant, using ASTC, we have that cosine is positive and everything else is negative. So cosine is going to be positive, sine is going to be negative, cosecant is going to be negative, and we've already got that tangent is negative and that cotangent is negative. Okay, so we've reviewed some sample problems from the 13 through